Hello everyone, let's talk about the final exam. I'm going to go through just a couple of types of problems from each unit. This isn't everything, but this is a lot of stuff that we've covered this year, and we're just going to kind of see how things go. If you can do this, you can do the practice final. There's not a whole lot I can throw at you that you're not going to be doing pretty well on. So first thing, you've got some exponent problems. One thing that might help you is to remember that that means square root. So this is what we're really doing, is finding the square root. And in the denominator, that's cube root. So if I say what's the square root in the top, you're like, well, square root of 64 is 8. And another way you could think about this problem is if you're looking for, that's not 6, is it? I did too many. If there's 6 A's underneath there, you could say, well, how many pairs of 2 are there? There would be 3. If there are 8 B's, there are 4 pairs of 2. So the square root, you could also think of it as multiplying your exponents. 6 times 1/2, 4 times 1/2. I'm sorry, 8 times 1/2 is 4. In the denominator, you have the cube root. The cube root of 8 is 2. There are one set of 3 A's if you have AAA and you're looking for sets of 3, and there would be 2 B's. So the last thing that you can then do is use your exponent rules. 8 divided by 2 is 4. If you have 3 A's in the top and 1 in the bottom, you could cross out 1 and have 2 in the top. And you could also have 2 B's. You could cross out 2 of the B's. So there's actually nothing left in the denominator. It's just 4A squared, B squared. Okay? Second one is a fifth root. So probably we would want to make a factor tree for 96. And I'm going to do that until it's odd. So 2 and 48, 2 and 24, 2 and 12, 2 and 6, 2 and 3. So this is the fifth root of, how many 2's do I have? 1, 2, 3, 4, 5 2's. 1, 2, 3, 4, 5, and a 3. And then x, 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 y, y, y. So I'm looking for sets of 5 because it's a fifth root. So I have 5 2's, I have 5 x's, and that's all I have. And the fifth root of 2 to the fifth is 2. So if you have 5 underneath, 1 makes it out. 5 underneath, 1 makes it out. What's trapped underneath? You have a 3, and then these 3 y's just don't have enough to make it out. So that's what you get. 2x times the fifth root of 3y cubed. All right, so let's see what we can do. Okay, let's go next slide. Oh, factor completely. So first thing, anytime you're asked to factor completely, you should always look to see if there is a GCF. And I know that 2 goes into 216, but does 8 go into 216? Let's do 216 divided by 8. 216 divided by 8. Yep, 27 times. So GCF, if at any time it says factor, do the GCF, is 8, and now you have x cubed plus 27. This is now where you go back and say, well, there's 2 terms. I'm not subtracting perfect squares, but I am adding perfect cubes. So what I'm going to do is now think this is the sum and difference of cubes. The cube root of x cubed is x, and the cube root of 27 is 3. So my a is x, and my b is 3. A squared would be x squared, ab would be 3x, and b squared would be 9. And then use SOAP. So it's plus, so it's same, opposite, always positive. That is your completely factored form. That's basically just, do you know the formula? Second one, we have some quantities. So in the numerator, I'll look at, let's see, what do these two things have in common? 5x cubed, and then they both have 2x minus 3's. But then what's left? Well, this guy would have an x minus 3 on the inside, and then minus 5x. That's just 1, because I factored out the whole thing. In the denominator, I can't really do anything, except I have x minus 3 to the fifth. So let's see, what else can I do now? I could cross out some of those. If there's 5x minus 3's in the bottom, I could cross out 2 of them and have 3 in the top. So I have 5x cubed. This would be x minus 4 over x minus 3 cubed. And there isn't really anything you can do beyond that, but that's pretty good. So now we'll try one of the really weird ones where you have the quantities. So this is going to be the weirdest. Let's see. There's 2. First of all, know that there are 2 terms. All this stuff is connected by multiplication, and all this stuff is connected by multiplication. So I'm looking at these two things, and what do they have in common? First of all, 4 and 8 are both multiples of 4. X squared minus 2 to the negative 1/2. One thing you hopefully remember is that whatever the exponent is, the negative one, that's the one that's getting factored out. And then 2x squared minus 5. This guy has 3 of them, and this guy has 2 of them, so I'll factor out 2 of them. What will be left on the inside? I factored out the 4. I factored out my x squared minus 2's. I factored out 2 of these, but there is another 2x squared minus 5 plus 4 times 2 gives you 8. And then this is where we have x squared minus 2 to the first. And the reason why is because you factored out a 1/2 and you're going to subtract a negative 1/2. So you factored out 1/2 minus negative 1/2, which is 1. That's why this is 1, because you're using subtraction rules. You're using division. 1/2 minus negative 1/2 is positive 1. And now on the inside, I'll simplify that. So this is 2x squared minus 5 plus 2x squared minus 4. So that's 4x squared minus 9. Wait a minute. That's dots. So 4x squared minus 2 to the negative 1/2, 2x squared minus 5 squared. And this is 2x plus 3, 2x minus 3. So super duper factorable. But that's okay. That's cool when that happens. Okay. What else you got? Let's see. Nonlinear inequalities. Okay, so knowing you have Desmos means you can kind of treat this problem slightly differently, but I'll do it algebraically. First, get everything on one side. Then factor. I'll factor out the 5 first. That's x squared plus x minus 6. And then the numbers that multiply to negative 6 and add to 3 are positive 3 and negative 2. Okay? Let's figure out where it equals 0. It equals 0 at negative 3 and at positive 2. So if I didn't have Desmos, I would say this is a parabola that if it's positive 5x squared, opens up and passes through negative 3, positive 2, and I also know that the y-intercept would be negative 30 down here. Okay, so that's negative 30, that's 2. Now, I want to know where it's greater than 0, because when I subtracted everything, I have greater than 0, so that means I want these guys. And first thing, these are closed circles at negative 3 and 2, because if you plug in negative 3, you will get 0, and 0 is greater than or equal to 0. So the interval notation would be negative infinity to negative 3, union 2 to infinity. I want this and this, to the left of negative 3 and to the right of positive 2, and the brackets mean those actually work. Now, if you didn't have this graph sketched out, you could graph it in Desmos and look at it that way. See, it's the same thing, but you don't need to know that much to know where the zeros are and know that it opens up. And if you don't know how to find zeros, then please don't take calculus or just factoring. Okay? Find the domain. So, two things. First, x must be non-negative here because you cannot square root a negative. And the other thing is we need to factor the denominator. So what multiplies to negative 2 and adds to 1? That would be 2x and negative 1x. 2x, x plus 1 minus 1, x plus 1, 2x minus 1, x plus 1. So I have at 1/2 and negative 1, I have discontinuities. So x cannot be 1/2 and x cannot be negative 1 because that's in the denominator. So on the number line, you could place negative 1. Well, let's do it. This will be negative 1. This is 0, and this is 1/2. And I need numbers that are greater than or equal to 0. So this is going to be a closed circle. These are open circles, and I'm shading to the right because I need to be greater than. So in this problem, it turns out negative 1 didn't really matter because we were never going to get to negative 1 anyway. We had to pick positive numbers. But our domain would then be between 0 and 1/2, bracket at 0 because it's closed circle, 1/2 is an open circle, and then 1/2 to infinity. So when I say find the domain, the two main things you should be looking for, you cannot square root a negative, and you cannot divide by 0. All right, that's our first unit. So let's go start working on the second unit now, which we started off with difference quotient. So I will give you the difference quotient. You don't need to have this memorized, but you do need to be able to use it. So the first thing that says x squared plus 1, I'm going to do a plus h squared plus 1. And then it says minus. F of a would be a squared plus 1. And the whole thing is over h. So when you FOIL, where this expands, when you actually write it out, you have middle terms. AH plus AH makes 2AH. And then I have plus 1 minus a squared, and then minus 1 because you have to distribute the negative. Every time you do this, f of a should cancel, and it does. So now I have an h, which I'll factor out, 2a plus h in the top. Those cancel out, and you end up with 2a plus h as your final answer. Difference quotient is one of those things that once you remember how to do it, it's usually pretty easy, but it takes a little while. Wait a minute. I feel like I missed a plus. I missed something here. 2ah plus h squared. Okay. Yeah, good. Okay, let's do another one. F of g of x. That means take g of x and plug it in. So instead of 2x plus 3, I'm going to do 2 times 4x minus 1. So 8x minus 2 plus 3 is 8x plus 1. And I can go the other way. This one says g of f of x. So that means take f and plug it into g. So not 4x minus 1, but 4 times 2x plus 3. So 8x plus 12 minus 1 is 8x plus 11. So we're cruising. Now we'll do some discontinuities. So we're going to need to, if you're finding discontinuities, you need to factor the denominator. The numerator is not going to change. But in the bottom, you have 1x squared, so what multiplies to 10 and adds to 7? X plus 2, x plus 5. Okay, so continuities at -2 and -5. And we need to remember that this one doesn't cancel, so that's called an infinite discontinuity. That's at x equals -2. And then we have a removable at x equals -5. Because when this equals 0 is -5, and that canceled out. So what you really end up doing is you end up looking at the graph of this, but there's going to be a hole in the graph at -5. So if I look, here's the graph, you can see that we have an infinite discontinuity. That's our vertical asymptote at -2. Yep. And then at -5, it says undefined. And if you don't know to look for that, you're probably not going to find it. So that's the tricky one. That's called a removable discontinuity, and it's removed, and the way I think about it is like the factor got canceled out, so it's gone. All right, polynomials. So end behavior, notice you're going to use limit notation, so this is what limit notation looks like. You say the limit of the function equals, and then I have one for going left and one for going right. Since there are 4 problems, I'm just going to go ahead and do that. You guys will be doing, it'll be matching on your test. So, all right, let's see, what do we know? Even, the degree is even, so that means it's either both up or both down. And you can see here's positive even, this is a +5, and here's negative even, this is a -2. So these are both even degree polynomials. One opens up, one opens down. So if they're even, both endpoints go the same way. Here, they both go up to positive infinity, and here they both go down to negative infinity. So as you go left, this is saying left and up, right and up. Left and down, right and down. Then if they're odd, this is negative odd, so that's like thinking negative slope. As you read left to right, it's decreasing. So as you go left, it goes up, and as you go right, it goes down. Left and up, left and up. Right and down, right and down. This one goes left and down, and then right and up, so up to positive infinity. There's only 4 things that can happen when you only have 2 endpoints, and you just need to remember those 4 things. And we made a little chart. That would probably be the best way to memorize that. Find all zeros. find some zeros. How about that? It says find all zeros, but let me remind you that if you are able to look at the graph, you can find a couple of the zeros. Now these are irrational, so I'm going to need to find those. But -2 and 5 work. So let's do synthetic division with -2 and knock this thing down to a cubic. 1, -5, -5, 23, 10. 1. So you multiply 1 times -2, and then you add. And you multiply, then you add. Multiply, add, multiply, add. If you don't get 0, you did it wrong, because I know -2 is 0. Do it again. So this time I'll do it with, what was it, 5? Yeah, 5 is also 0. So I'm using these coefficients. Bring down the 1, 5, -2, -10, -1, -5, 0. Okay, good. 0. So I have x squared minus 2x minus 1. I factored out an x minus 5 and an x plus 2 using synthetic division. To find the zeros for this, nothing multiplies to -1 and adds to -2, so I have to do the quadratic formula. So 4 plus 4 is 8. So when I do the quadratic formula, the opposite of b, 2 plus or minus radical 8 over 2a. 2, 2, 2, that's 2 radical 2. So 2 plus or minus 2 radical 2 all over 2. And when you distribute, 2 over 2 is 1 plus or minus 1 radical 2. So 1 plus or minus radical 2, positive 5, and -2 are my zeros. And if you want to check those, it's not a bad idea to kind of look at your Desmos or your calculator and check to see if those zeros match. 1 plus radical 2 and 1 minus radical 2. So are my other zeros at -0.4 and 2.41? Yup. Good. So that's 2 zeros, 5, and -2. That's all 4 zeros. Carrying right along. We're cruising. Determine if it's a factor. Okay, there's a couple ways you could do this. One thing, you could do long division, or you could do synthetic division. I'm going to do synthetic division, and if it's a factor, that means there should be no remainder. So I'm going to just do 6, -26, and 12, and I'll plug in 4, multiply, add, multiply, I got a remainder. Okay, so if you get a remainder, that means it doesn't divide evenly, so we'll say no, 4 is not a factor, or x minus 4 is not a factor because there's a remainder. It should be remainder 0. So, okay, that's really all you can do. All right, rationals. So rationals is a lot of factoring. I can do the top in my head. Y minus 6, y plus 3. Can we do the bottom? Let's try the bottom here. It's going to be 2y. I need numbers that multiply to 6 and add to 5. So 2 plus 3, 2y squared plus 2y plus 3y. That makes 5, and 3 times 1 is 3. There you go. Okay. So I factored it, and then what? Nothing cancels. So this is simplified. That's lame. Usually when you do these, something cancels out, but nothing did, so this problem is kind of silly. I just factored it, but I factored to try. I guess I tried. Just nothing happened. All right, let's go nuts here. Analyze this thing. So remember, to find x-intercepts, you need to factor the top. X squared plus 5x minus 6, which would be x plus 6, x minus 1. So I should have x-intercepts at -6 and positive 1. And that's because I just factored the top. Y-intercept, when you plug in 0, ignore all that, -12 divided by -6 is positive 2. Asymptotes, these have the same degree, so the horizontal asymptote would be 2. The vertical asymptotes, when you factor the denominator, x plus 3, x minus 2, are at -3 and positive 2. Now, analyzing it, you should be able to do algebraically. If you're going to graph it and you got Desmos, ta-da. Look, I've got x-intercepts at -6 and positive 1. I've got a y-intercept at positive 2. I have y equals 2. That seems right. It's very small, but and then I have -3 and positive. Yeah, okay, good. So analyzing it, yes, you should be able to do. You could graph it too, but if you have Desmos, what are you doing all that for? X-intercepts, x minus 4. Oops, these are not what I want. X minus 4, x plus 2. So x-intercepts are at 4 and -2. Y-intercept, wait a minute. You can't plug in 0, so there is none. And that means that x equals 0 is an asymptote. The denominator cannot be 0. So when you analyze it, you're like, well, I got those. But wait a minute, there's a slant asymptote to this. So let's do long division to find the slant asymptote. This is top heavy, so I know there's a slant asymptote. And it's going to be really easy to find. X times x, I'll just say like plus 0x. Or just plus 0, really. It's not even an x. It's x. Flip the signs, minus, minus, and you end up with -2x minus 8. Go one more time. X times -2. -2x plus 0. The remainder is -8. That doesn't really matter. What you care about is the slant asymptote is x minus 2. So x minus 2 is your slant asymptote. And again, you might be asked to find that. So here's the graph. X minus 2 is in green. You have intercepts at -2 and positive 4. There is no y-intercept because you have a vertical asymptote at x equals 0. Cool. All right, home stretch. We're on logs. Whoa, what happened to my... That's crazy. I think I fixed it. Last thing, logs. So condensing logs, we're going to take the coefficients, and those are going to be exponents. So we have the log of x to the 4th minus the log of x squared plus 1 to the 1/3 plus the log of x minus 1 squared. Then I will condense. So these, subtraction condenses into division, x to the 4th divided by, I'm going to write this as the cube root of x squared plus 1. 1 to the 1/3 power is the same as cube root. And then I have this thing. I'm going to condense that into multiplication. So this times that. This is just in the top. That's all you really need to think about. This would be x to the 4th, x minus 1 squared over this cube root. So kind of messy, but let's just follow those laws, those rules. Exponents become, or coefficients become exponents. Subtraction condenses into division. And addition condenses into multiplication. Going backwards, division will expand into subtraction. Then I could bring the 2 down. I'll probably have to be careful here. B to the 4th plus the log of c to the 1/2. I'm going to do a couple things at once. First of all, you're subtracting this, so you better put parentheses because you're going to mess up the signs. That's the easiest thing to do. So this is minus, when I bring the 4 out, 4 log b, and then minus 1/2 log c. You got to remember to distribute. Because all of this is in the denominator, they should both be negative. So 2 log a minus 4 log b minus 1/2 log c. Solving. All right, so if you see a base e exponential function that is isolated, we're going to write this as a natural log. And we're going to try and figure out, let's see, it would be e to the x plus 2 equals 10. Okay, if you think of natural log as base e, e to the x plus 2 is 10. I don't really need to write that. So this is the natural log of 10 on the left side. That's what, these two things are interchangeable. Okay. Now, if you want to get x by itself, you would say take the natural log of 10, and then you would, I'm going to put that in parentheses, subtract 2 from it. So the natural log of 10 minus 2, or you could write it as negative 2 plus the natural log of 10. So I'll say the natural log of 10 minus 2. Just make sure you close your parentheses, and you get that. So 0.3025. Which I think we've been doing 4 decimals, so 0.3026. If you have an isolated log, rewrite it as an exponent. So 2 cubed is 25 minus x. 2 cubed is 8. Subtract 25 from both sides, you get negative 17 is negative x. That means that x must be positive 17. And the last one. This is probably the most annoying. So I'll take, if I have a base 3 logarithm, I will take the base 3 log of both sides. When you do that, on the left side, you could bring this x plus 3 down, and then you have x plus 3 times the base 3 log of 3. Now, we don't even necessarily need to write that step because that's 1. So it's x plus 3 equals the base 3 log of 5. So if you want to get x by itself, take the base 3 log of 5 and subtract 3. And I can just use my calculator, and I have my fancy calculator. So I'll say the base 3 log of 5 minus 3. So the answer is right there. Negative 1.535. Done yet? All right. One more. So last problem. Model principal is 1,000. Interest rate, 0.09. Time, don't know, t. That's the thing I don't know, t. So if you want the balance over time, b of t, the balance over time is 1,000 e to the 0.09 times t. Now if you want to know when there's $2,500, well that's a balance. So let's set the left side equal to $2,500. I can't rewrite it as a log until I first get everything on one side that except for the exponent. So that's 25 divided by 10, 2.5 equals e to the 0.09t. Okay, so first thing I'm doing is isolating the logarithm. The reason that I'm doing that is because I need to rewrite it as an exponent. Well, it is an exponent. I'm isolating the exponent so I can write it as a log. To undo this, I'm going to take the natural log of both sides. Natural log of e to the 0.09t. And when you do that, this is going to come down 0.09t, and the natural log goes away on the right side. Because natural log cancels out the e. This comes out, and the natural log of e is 1. So you just think of it as, okay, I'm left with the exponent. And the last thing I'll do to get t by itself is divide by 0.09. So I have to do the natural log, 2.5, divided by 0.09, and I get 10.1, 10.2. T is 10.2. So what does that mean? 10.2 years. In 10.2 years, you will have $2,500 in your account. We started with $1,000, and in 10 years, at that rate, you'll have $2,500. But you had to use logs to get there. Whew. Well, that's a lot, but we did it. Like I said, if you can do this and you can do all those other things, then you can definitely hit that like and subscribe button, and you can definitely get an A on your final. So good luck.